Okay, so what does this problem say? Your ear is capable of differentiating sounds that arrive at each ear just 0.34 milliseconds apart, which is useful in determining where low frequency sound is originating from. Suppose a low frequency sound source is placed to the right of a person whose ears are approximately 18 centimeters apart, and the speed of sound is 340 meters per second. How long is the interval between when the sound arrives at the right ear and the sound arrives at the left ear? Assume the same person was scuba diving and a low frequency sound source was to the right of the scuba diver. How long is the interval between the sound when the sound arrives at the right ear and the sound arrives at the left? If the speed of sound in water is 1500 meters per second, what's significant about this? Okay, so let's get a drawing going. And here's the source of sound, and this is the left ear, this is the right ear. It's this is the distance. Okay, so the time difference between the arrivals of the signal is the distance apart divided by the velocity of this sound. Okay, and you can see the greater the velocity of the wave, less time it takes for the wave to travel this distance. Okay, so in air the velocity is about 350 meters per second for sound, and in water it's about 1500 meters per second, so which is 5 times greater. So the time difference, arrival time difference in water would be 5 times less. Okay, we'll draw a wave from here. Okay, so in air, delta T is D is 18 centimeters, so 18 into 10 minus 2 meters, and velocity is 340 meters per second, and we'll bring 1 0 up there, so that becomes 10 to the minus 3, so 18 over 34 into 10 to the minus 3, and the meters cancel second, so this is a millisecond. Okay, so this is equal to 1. Okay, so what that means is, since the time difference is for the two waves to arrive between the left ear and the right ear is 0.53 milliseconds, we can tell if the sound is coming from the right or the left. Okay, so you can locate the source of sound. Okay, now let's do the same problem underwater. So underwater it would be d over v equal to, again, 18 into 10 minus 2 meters divided by 1500 meters. And so if we do the same calculation, we're doing the same calculation, 150 10 minus 3, and you can see it's 0.12 milliseconds. Okay. So underwater, the time difference is not large enough for you to be able to tell the direction from which the sound is coming. So this is the same as if the sound were coming from here, there, or anywhere. So you lose the directional localization capacity underwater. Okay, so that's part C. But anyway, so we'll end here.